I have a generator that has an L5-30 output receptacle, 120 volts, 3 plug. I'm rigging up a box to backfeed the power into my breaker panel in case of a power outage. Yes, I know which breakers I need to flip in the event. The power input boxes only come with L1430 plugs. I have a converter cable coming to solve the plug compatibility problem. I'm thinking that those conversion cables, pigtails, connect the X and Y wire to the one hot wire of the L5-30, essentially splitting one hot into two. So on the breaker panel end, can I use a tandem breaker, normally for 240 volts since it taps both hot buses, to pump 120 volts into both buses?
Have you talked to an electrician about your outlet?
No.
How long has this been going on with your outlet? What have you tried so far?
Read the issue.
Is there anything else the electrician should know before I connect you? Rest assured that they'll be able to help you.
No.
Hello and welcome to Just Answer. My name is I will be happy to assist you with your electrical question. My background includes 34 years as a licensed electrical contractor, residential, commercial, industrial, in Illinois, retired AT&T telecom engineer, adjunct college electrical instructor, former electrical inspector, 2X graduate from DeVry Institute of Technology with certificate in telecommunications installation and diploma in digital electronics, FCC amateur and commercial radio licenses. I am also a certified construction manager for residential construction. I previously held a state of Illinois home inspector's license. I'm sorry to hear you're having problems. I know that can be frustrating, and I can empathize with your situation. Hopefully, we can get this resolved quickly. 1. A NEMA L5-30 can only supply 120 volts at 30 amps and not 240 volts. Therefore, it can only backfeed one phase on the panel and not both hot phases. 2. A NEMA 14-30 is a combo of both 120 and 240 volts. 3. Unfortunately, the generator is only capable of generating 120 volts and you cannot backfeed to the two hot phases on the panel. You would require a generator that has 240 volt capabilities.
In that case, do I wire both hot sides from the L1430 to a single 38 breaker on one half of the panel? I'd be switching off all 240 breakers if I have to use the generator since it only produces 120 volts. So some of the essential equipment, refrigerators, freezers, lights, are on both sides of the panel. I'm not looking to get 240 volts on any circuit, just 120 to both sides of the panel. I guess the fundamental question is on this conversion cable, pigtail. When they connect the one hot from the L5 to two hots for the L14, are they having the voltage on X and Y or are both still 120 volts?
1. Your generator is not capable of providing 240 volts, can only produce 120 volts on one phase. Pick a phase for the 30 amp single pole backfed breaker and relocate your critical circuits to one of the hot phases on your electrical panel.
I think you might be misunderstanding what I'm getting at. I know the panel has two 120 volt sides, X and Y, so if you need 240 volts, you use a tandem breaker that taps each side to provide 240 volts. If I'm not looking to get or use 240 volts and switch off all the 240 breakers when I'm on generator power, can I pump 120 volts, the same phase, to both sides of the panel from the L14 connector? Essentially, I'm combining both hot buses into one when I do that. But if I have to switch essential equipment to one side, what gets wired to the single pole breaker, one or both of the L14 hot wires?
1. How are you going to send 120 volts to each panel phase when the generator is only capable of 120 volts? If wanting 120 volts on each panel phase, you need a 240 volt generator. 2. Your generator requires a NEMA 5-30 power inlet, a 5-30 cord and a 30 amp single pole breaker. See this link at the depot for the flanged power inlet. https://www.hamadepot.com/p/ac works 30 amp locking 3-prong 125 volt NEMA L5-30p flanged power input inlet ASM 530p/30543666613. The L1430 is useless and is the wrong product for your application. The generator can only provide 120 volts to one of the phases only and not both phases. If a 120 volt generator could provide 240 volts to each hot phase, then the generator manufacturers would not be selling 240 volt generators. 4. In summary, you only have 120 volts available and you will not be able to backfeed the generator to the panel on both phases. 1. A tandem breaker only resides on one hot phase and not on two hot phases. A full-size double pole breaker is used for two hot phases to provide for 240 volts.
Pardon my terminology, should have said double pole instead of tandem. But, I fully understand the panel. X on one side, Y on the other, and when you use a double pole breaker, you're using both X and Y to get 240. But if I'm not looking to get 240, again, switching off anything that uses 240 so it's no longer an issue. So what happens to the voltage when the one hot from the L5 is split to the X and Y of the L14? Are both X and Y still 120 or are they each 60 volts? If they're each 120 volts, I can connect one to one side of the panel, and the other to the other side of the panel, essentially making one bus out of two since I'm not going to be using anything that requires 240 volts. Both sides would be using the same phase.
1. Once again, you cannot split one single 120 volt generator output into two separate hot phases on the panel. 2. You're mixing apples with oranges. Why are you using a NEMA 14-30 when the generator is only capable of 120 volts and is not capable of a combo 120-240 volts? The L1430 is useless and not required. A 14-30 is only used for a 30 amp generator that has a NEMA 14-30 receptacle which provides a combo 120-240 volts. Your generator can only provide 120 volts on the output. Doesn't matter what you do at the panel side. 3. A double pole backfed breaker cannot be used since the generator only has one hot phase and a double pole breaker requires two separate hot phases. You are not understanding how a generator and an electrical panel works. 4. Hot to neutral on each phase is 120 volts. Phase to phase, hot to hot, is 240 volts. Phase to ground is also 120 volts. No such thing as 60 volts.
Okay, I get it. I spent hours looking for a weatherproof power input box that had a receptacle, plug that had an L5 configuration. None are available. The only option I had was the L14. Online, there were lots of folks who used the conversion cable with success. But I'm thinking out of the box here. I fully understand the panel. One side is X, the other side is Y. A double pole breaker connects to both X and Y, giving you 240 volts, but only if you're going to use 240 volts. But thinking this another way, outside the box and thinking through the logic of what's happening, the generator is only supplying 120 volts. If I'm not going to be using 240 volts, there's no need for both X and Y on the two panel buses. I'd be putting the same phase to both sides. Again, since I'm not looking to use 240 volts at all, I'm making both sides of the panel into the same phase or side. How is this an issue if everything that will draw power is 120 volts? I looked at the plug you sent in the link. I have to rig up a different weatherproof box to house this thing, and I'm not sure if all the other parts are available. Box with cutouts, mounting flange, weatherproof cover. The L14 box I have on order is all-inclusive. The only question is the wiring connections. Again, I'm not looking to get two phases to get 240 volts since I'm shutting off anything that uses 240 volts, just looking to get 120 volts to both sides of the panel without moving a lot of breakers, circuits in the panel. So if I have to go on generator power, which I will next week due to a scheduled power outage for maintenance, my solar system gets shut off, the main gets shut off, and any 240 loads get shut off. I appreciate your expertise, but I'm also an engineer at heart, granted, not an electrical engineer, but I know that having an understanding of how things work can often allow you to arrive at a solution where a cookie-cutter aspect doesn't provide one. I actually wanted to get a bigger generator that had 7,500 watts, 240 volts, but last year we had an unexpected power outage that necessitated getting a generator ASAP. Good luck finding the generator you want during a power outage. This one was the only one available that day and I was grateful to find it, so I'm kind of stuck with it. Don't really want extension cords running everywhere, so that's why I'm trying to get a clean solution to feeding power from the generator into the panel to eliminate the cords. Since I'm not going to need 240 volts, shutting off any 240 volts load, I have no need to have two separate phases, one on each side of the panel. If I use the L14, it's going to be ready if I eventually upgrade my generator, providing 240 volts on two separate phases. But like I said, thinking outside of the box and understanding the flow, if I use a double pole breaker, I think for the short term, I'm putting the same phase to both sides of the panel. Again, since I'm not needing or using 240 volts, that shouldn't matter. Then if I upgrade to a 240 volts capable generator, I don't have to change anything and I can then actually have 240 volts capability since each side will then have a separate phase. This is probably much deeper thinking than the issues you normally deal with, but that's my engineer hat seeing an out-of-the-box solution that will work.
1. Since a 5-30 weatherproof flanged power inlets are not available, I recommend to install the flanged inlet on the inside of the garage. If an attached garage, the flanged inlet can then be installed into a gray electrical PVC box, which are also sold at Home Depot. 2. You could use the 14-30 box, but then you would need to make up a cheater cord to connect the generator receptacle to the 14-30 flanged inlet and only connect the one hot wire from the cord to the inlet. Then from the inlet to the panel, would need a 3-conductor circuit, 1 hot, 1 neutral and 1 ground, to the 30-amp single-pole breaker.
I have the power inlet box, cheater cord, and longer L14 to L14 cord on order. Don't have an attached garage, which is part of the problem, everything is outside. Power panel is an externally mounted panel since I had to replace the Zinsco panel when I remodeled the house. So from the generator, I have an L5 male to L14 female, prefab cheater cord, pigtail, then a L14 25 feet extension cord that plugs into the L14 weatherproof box. That allows running the generator away from the house to avoid CO problems. I have a liquid-tight power whip that will connect the L14 box to the panel. All external to the house. Now, within the conversion pigtail, it's only 1 foot long. I assume the one hot wire from the generator is connected to the X and Y black, red wires within the pigtail. I assume both are 120 volts, correct? The power then transits the extension cord into the inlet box and from there to the wires going to the panel. When I connect those wires, if I only use one side, I'm limited to one side of the panel. But if both are 120 volts, I can energize both sides of the panel, again, not looking for 240 volts, not using 240 volts, connecting the red wire to one terminal of a double pole breaker and the black to the other terminal. I have the same phase supplying power to both sides of the panel. If I upgrade to a better generator in the future, this will be pre-wired to allow 240 volts. Does that make sense? Granted, if I upsize the generator, I might have to upsize the wiring and breaker also. But that's easier than rearranging the breakers in the panel, especially since I don't have much flexibility in the wire length in the panel.
1. If backfeeding using only 120 volts to a 240 volt panel, the 240 volt circuits will not work. If you have shared neutral circuits, the neutral wire could also overload. Not recommended for potential safety issues. Best to purchase either a 30 amp or a 50 amp portable generator that will provide a combo 120-240 volts. If you have any additional questions, just let me know and I'll be glad to answer them for you. Thanks. Kevin.
Thanks, Kevin. Sorry for the delay, had to do my day job. No shared neutral circuits in the house, I don't believe in doing things that way. Appreciate the help, I think this will work. Don't need 240 when on generator power since the generator doesn't have the output for the range, tankless water heater or AC anyway. Those can wait until I have the grid back.
Okay, very good. You're welcome. No problem, glad to assist. Take care, stay safe and have a great evening. Thanks. Kevin. Thank you for the acceptance as well as the bonus. Both are very much appreciated. If you have any other questions, just let me know. The next time you have a home improvement or an electrical question, place my name on the question and send it to my attention, Kevin, and I'll be more than happy to assist you. Take care and have a great weekend. Thanks again. Kevin.
If you have a home improvement or appliance question and want to chat with an expert now, visit justanswer.com/ythi.